I hope you're ready now for our next speakers. We chatted about them earlier. That's going to be, there we go, Dustin Goodman and Tracy Lee, GraphQL in the enterprise. I don't know what that is. All right, ladies and gentlemen, boys and girls, children of all those ages, please go crazy, make computer sounds for Dustin Goodman and Tracy Lee.
Thank you for the amazing introduction.
Yeah, that was awesome. Thank you so much. I am just getting the screen share going.
I think you're coming in a little quiet, Dustin.
I will fix that.
Seems better now.
Well, hopefully I just did this right and everybody can see exactly what we're hoping they see.
Yay, looks like everyone's good. Hi, Becca. Cool. Should I get started?
I think so.
Okay, so super excited about this talk today. Super excited to be platinum sponsors of MagnoliaJS, especially to support an amazing woman in tech, Kayla. So thank you so much, Kayla, for organizing this. Today, we're going to be talking about GraphQL and how you can use it to leverage and upgrade your stack. My name's Tracy. I'm the CEO of a company called This.Labs. We do JavaScript consulting. Love being a part of the community. I'm a Google developer expert for Angular and the web. I'm on the ArcsJS core team, Microsoft MVP, and I just do a ton of things in the community. So if you want to come hang out, you can always find me on Twitter, again, at LadyLeet. And again, we're hiring, so feel free to drop your resume wherever you can find me.
And I'm Dustin, and I'm an engineering manager at This.Labs. I'd love to work with you as well. And I'm really excited to be giving this talk with Tracy today because I love GraphQL, and we've had a lot of fun integrating this in a bunch of enterprise environments and wanted to share some of the things we learned.
Yes. One of the reasons why we put this talk together is just to help developers sell GraphQL a little bit better to their teams and their managers, and or if you're a manager too, this is really useful because hopefully it helps you understand why GraphQL should definitely be implemented. So we're going to talk about a few things today. First off, what is GraphQL? We'll go over kind of the differences and advantages of GraphQL over REST. Then we'll kind of look at why enterprises tend to adopt GraphQL or what good reasons are for adopting GraphQL. And then we'll talk a little bit about the GraphQL ecosystem and tooling. So to start, what is GraphQL?
So GraphQL is going to be a query language for your API. In the traditional REST APIs, we had all our different endpoints. What GraphQL does is it brings typing into your API and just gives it a new level, a new set of definitions and information to allow you to create these richer interfaces. It does a lot more. We're going to talk about that. But what's really nice about GraphQL is it's going to let you specify exactly what you want to retrieve through queries, how you want to modify data through mutations, and even give you event listeners and data streams through their subscription services. And we're going to see a bunch of advantages that this is going to give us over REST. And it's also the biggest thing that this really fixes is it helps with the communication layer between backend and front-end teams because of the way that GraphQL's query language is structured. It defines this rich language of types and objects that now front-end teams and backend teams don't need to go bouncing back and forth on all the time. So definitely a big communication boost right there and a great benefit of GraphQL. So really where we want to start is how is GraphQL going to solve some of REST's pitfalls? So it's important to acknowledge that the most expensive, resource-intensive, and time-consuming part of any client-to-API communication comes from the HTTP request and all the response processing. So with that, we kind of want to look and see how GraphQL solves some of these. And let's let Tracy take the first one. Oh, actually, I lied. The query language. Sorry, I jumped ahead a slide. So our first thing that GraphQL is really going to do is it's going to create that rich data format language. So we talked about it a little bit a minute ago, but if we look here, we can kind of see, hey, we have a query that's going to retrieve a single user by ID, and it's only going to return these specific fields. And what's really awesome is comparing the GraphQL syntax language on the left to the actual data we retrieve on the right, you can see that the shape of the response matches the input that we gave to the server to generate the data request. So this is really going to help us uh, kind of identify exactly what our data is going to look like, its shape, even before we get to the server, before we ever make that first request. Really powerful, really easy way to kind of have that communication layer.
Yes, and now my favorite part, talking about underfetching and overfetching. So one of the major problems that GraphQL solves is just improving performance by optimizing the data retrieval process. Not to say that GraphQL is going to solve all your performance problems, because we definitely hear that, like, oh, GraphQL solves performance, let's do it. But one of the things is with REST, one of the key problems is underfetching, right? Or not getting enough data back with your request. So usually you have to either make multiple calls to fetch all the required data, or maybe the client has to provide additional query parameters, and those are typically poorly documented or hard to understand. But the great thing about GraphQL is you're able to request the data you need in full with a single request, and that eliminates all the multi-requests and allows you to specify the additional data in a clear manner. So the other side of it is overfetching, right? Or getting too much data from the server. So because REST doesn't provide an out-of-the-box mechanism for us to retrieve only the data we need from a request, this can lead to clients having to consume and parse or handle too much data, or maybe server responses are taking too long to return because the requests have become too large. So a great example is, I was working on this one project where a request for a page where it had to fetch like megabytes of data to render correctly. But with GraphQL, the cool thing is you can just remove all that superfluous data from the request, and that'll help reduce the payload size and data required to parse. So over here, you can kind of look at how REST does overfetching, right? So here we're going to have a requirement to display a list of users to view in a table with their last comment and post. Our user object can be super large and contain tons of different fields and properties that we know about the user. Maybe it has like comments, posts, when they were created, last updated, but like you don't need or want all that data that comes back if you just want the basic details. So here you can see how you could have requested this data in a REST API, right? It gives all the user fields and a list of all their comments and posts. But the issue is that this request takes just so much longer to return and has more data for the client to parse because we don't know the exact shape of the data. And unfortunately, that means our users pay the price for slowed response and render time. But if you look at GraphQL, the reason why GraphQL is so awesome is because you can see here the GraphQL query, and it selects the exact data that we need to display. So list of users with their last post and comment. And now we only have the lightweight response data to display. So this will help reduce both server response and client render, which is awesome.
Then another problem that GraphQL does a really good job of solving is the all or nothing problem. So in traditional REST, how many times have you made a request and just gotten a 400 or 500 error from the server? You got no data. Sometimes you get an obscure response error. Sometimes you get no error, just kind of variation of things. Well, what GraphQL does a really great job of is it now creates a user experience where we're going to get any of the data it was able to retrieve, as well as the exact errors that happened on any of the specific fields where it wasn't able to retrieve that specific data. So no more blank error pages or just generic catch-all 500s. You can now just handle the specific request piece that failed and generate data in that way. So in our example here, in a REST example, maybe we had a user getting comments. And so we would have had to make a request for user and another one for comments, or in the overfetch case, we put user with a query param for comments and we'd get all that data. Now, let's say comments failed on the back end for some reason, then we would have gotten no response whatsoever. So here what we can see is now we have actually the user data we requested in our original query. And then we can see that comments didn't come back, but we also get a message about why comments didn't come back. Now, obviously this isn't the best error message in the world, and this is something we could make better as we're iterating on our API and trying to improve things, but definitely something that is cool that GraphQL lets us kind of customize this and create any variation of error messaging and pathing. A lot of power there. Also in development mode, what's really powerful is you can actually enable stack tracing. So if you have connection to your server, want to see exactly where it failed, you could provide that information through your server back into GraphQL, and it will show you in the developer console as you're typing, which is really helpful. Another problem that GraphQL really does a great job solving is batching. So out of the box, REST just doesn't support this whatsoever. If you're making these rich dashboard pages, you're going to have to make a request per widget typically. And this creates a lot of back and forth between the client and the server, and you're not getting as much data as you want as efficiently as you could. So then you have to go and create custom REST solutions for batching. It's not very productive. It's a lot of overhead to get a working solution. And what's great is GraphQL actually ships with the ability to do these batching operations out of the box. So to kind of show you here, we have a dashboard query. And I want to fetch some information about the current user, some sales information, and some marketing information. And what we've done here is we've actually created 3 query operations, or 3 accessors, and just grouped them together in a single operation that goes to the server. Server handles all of that data batching, and then on the output side, we can see we get that same shape we put in with all our additional data. So this is going to be great for generating dashboard type pages. The one pitfall here is batching still has the added cost of you have to do multiple requests on the server, and this could slow things down a little bit. So we don't necessarily recommend doing this for all pages, but we definitely recommend doing this on the server side and fetching that data as you go.
Cool. So now we've kind of explored some of the problems that GraphQL solves. And like Ava said, yes, custom REST solutions for batching is the worst. So let's talk a little bit about why enterprises are adopting GraphQL. So next slide is the separation of concerns. So the first reason is the ability just to create a separation of concerns by adopting a GraphQL middleware layer. This isn't something that everybody decides to do in terms of adopting a middleware layer, but it is extremely useful. And the reason why I love it so much is because then the API layer can just be concerned with how to retrieve and return data instead of having to build out multiple endpoints and data structures and exposing the data that the client needs. It also helps increase API flexibility and decrease API development because the middleware layer, again, just exposes one connection for the clients to consume. It centralizes the business logic and all the common things like request logging and authentication. And now, because the structure and definition of the data is provided by GraphQL, then the client can just focus on consuming the data it needs and be less concerned about how to actually retrieve it. So another benefit of this separation is that API teams, are typically wanting these days to migrate monolithic API architectures to a microservices architecture. And again, because now the business logic is centralized, and the GraphQL is now responsible for client interaction, then APIs can evolve over time with business requirement changes, and the client doesn't have to continuously make changes to accommodate, et cetera, et cetera. So even if your company isn't thinking about microservices architecture, GraphQL can just act as a proxy for your data, which is nice. Another advantage to GraphQL, which is one of my favorites, is faster prototyping and development, because who doesn't want that, right? There's so many ways to approach GraphQL adoption. We tend to recommend a schema-first approach. One thing you can do is you can just start by defining the data structure and building your schema and adding, types and queries and mocking out the data response. And the great thing about this is that the client can now immediately see the definition of the data as it evolves and start developing against it using the mock data while the real API and data layers are being built and validated. So this is awesome. And of course, client and API teams both have to agree upon a data structure up front, right? But the great part about this is, decreasing development cycles, decreased time to market, and you no longer have to say, I'm waiting on endpoints from John 24/7. So I think it's a pretty magical thing that GraphQL helps solve.
Another thing that GraphQL is just really great at helping is the adoption of component-driven architectures. When you know the structure and the definition of your data, your components can now request and retrieve only that data that they need in order to interact and display. So this makes it really great in ecosystems like React and Angular, where you can abstract away all your service layers. But what's also nice is with tools like Apollo, which we'll talk about in a little bit, you get some out-of-the-box caching. So some of that state management you might have been doing with NGRX or Redux previously, you kind of get for free with the Apollo client and some of that tooling. So this means you're going to be able to create a lot of smaller stateless components that can be reused everywhere instead of worrying about, oh yeah, I need to go parse all this data before I can even show this thing. I need to make sure that my request is fulfilled before it displays and make sure that these pieces actually made it back from the client. It's all built into kind of how you build your components now. Much more streamlined approach. Another thing we're seeing that makes the adoption of GraphQL just really strong right now is strong typing. We're just kind of seeing this comeback of strong typing. Everybody loves TypeScript these days, right? So what's really great is now with GraphQL, you're able to write all your data in an intuitive data-driven way. Each individual field as well as objects are going to be defined in types, and this is going to help your entire API be more resilient to data and less error prone, which is really great. The other side of this is when you're creating mutations or data post requests in a traditional REST sense, you're going to be able to know before you ever build out that request what the data shape should be. You don't have to go look at the docs and try to interpret, is that a number? Is that a floating point? Is that a formatted string? You just get the type out of the box and it's like, oh, this is going to be a number, or hey, it actually needs to be this specifically framed string. And that's something that GraphQL is going to provide you out of the box. And it's just going to improve that developer user experience and help you, again, decrease those development cycles because you're not going to have to be guessing how to build things. You're just going to be told by the documentation that it's generating right there for you.
Yeah, so next we're going to talk about how y'all could probably start adopting GraphQL. We're going to walk through some of our recommended approaches, and hopefully this gives you all a safe path to migrating going forward.
So we've talked about the GraphQL schema definition language, or SDL, and this is going to be an example of what a schema file can look like. And this is where we recommend starting. With all GraphQL APIs, you're going to have your kind of data layer. You're going to have to understand how is your data related to each entity? What are your entities going to be called? How are they shaped? What is the data? What's really great here with the SDL language is that we can see exactly some of those shapes and generate documentation from this. So to kind of look at this specific example here, we created a numeral type called role, which gives you two values, user or admin, that we can now use to define a user object later down in this example. So if we look at user now, it has an ID of type integer. And that shebang there just says, hey, this is a required field. So anything without the shebang is like, hey, it's optional. You don't, this could be a null value. So in our case of comments down below, like it's an array of comment objects. Comments can now be null sometimes. So we're gonna have to handle that erroring. Is that the best case? Probably not. We should probably shebang that and then make the internal comment itself optional. Something we could change here, but just showing you how we could develop some of these schema entities and types. So again, with user, we have role, but the really powerful thing here is you can now see that comment and user know about each other. A comment belongs to a user has many comments, and we can retrieve that data directly, and the types are interrelated. So now we have the graph side of GraphQL, hence its name, and we can interleave these two things. So you can actually go from the user back to the comments and the comment back to the user several times. Not recommending that pattern, but it's something you can definitely do. Finally, at the end here, we have the query type, and this is where GraphQL is going to start being a little protective of names. So query, mutation, and subscription are their three internal operations. And what we could do is now we can define these different operations upon these types, and that's how we're going to interface with our API. So from earlier, if you remember, we did a user query. Well, this is how we would define that user takes a integer for the value of ID and then produces a single user object. So now we get to see all the power of our schema in play and how it can relate, which is great. Now we're starting to visualize data and see how we can go from A to B and back again. But then how do we actually get the data? We've defined our types. We need to be able to now connect the types to data. And that's where resolvers come in. And this is maybe the most powerful thing in GraphQL. Resolvers are going to be what's responsible for fulfilling any given request. And what's really nice about the resolvers is they're allowed to behave in any number of ways. And this makes the migration pattern a lot easier, or the adoption. So what we can do is we can actually make it so resolvers call other service layers. We can make it so they connect directly to our database and retrieve data. We can also make it so they request data from other services or sources through HTTP calls. We can do a varying number of other strategies, but these were just a few for an example. So resolvers are really powerful in that they can go around and just fetch that data, make sure it's formatted correctly, return it to the types validate it, and return it back to the user. So pretty powerful stuff. So just to kind of look at a quick example from our previous earlier example, we had the query for users, the query for user, and then we had on user the comments property. This is an example from Nest.js, and just kind of shows how you could quickly define user resolvers. So in this case, we have users, user and comments all relying on a third-party API. So if you're in the process of doing a migration, this would definitely be a great strategy where you leave your existing services up and just rely on them to fetch your data and just make sure you're formatting your requests here. This abstracts things away, and then when you're ready to move to a different pattern, you only have to change the code once, and that's at this layer. Additionally, there's some directives that you can get. Every framework and language has its own means for doing this. So just refer to your local documentation. It'll tell you exactly how to do it. It's always very clear, though.
So another thing is migrations, right? So the goal when adopting GraphQL and doing schema first is kind of to allow teams to communicate as they build out and define the schema. So basically, as this is starting to get built out, clients can start incrementally adopting and utilizing the layer. So this is really great because I think it just allows for that incremental adoption, and it hopefully helps increase productivity and engagement with engineers as they get to utilize and see the power of GraphQL as it's continuously built out. It also helps simplify the code base, right? We talked about centralizing the business logic. So many companies have talked about how this has just been like one of the most amazing reasons why you should adopt GraphQL. But it's great to kind of start doing that incrementally and just move all the business logic out from the client code. So last part is just talking about the GraphQL ecosystem. One of the amazing things about GraphQL is the growing ecosystem. If y'all haven't checked out GraphQL-meetup.com, we also host GraphQL Contributor Days, State of GraphQL, and also GraphQL trainings with Eve over at Muna Highway. So definitely check that out. It's all free. But we'll share some great tools and resources available as well to help you build out your GraphQL ecosystem that we recommend. One of them is Apollo. I feel like Apollo platform is basically synonymous with GraphQL these days. It provides a lot of tooling to aid you in building, querying, and managing your app's data graph. It also has Apollo Server, which helps you build out your graph's SDL and connect it to existing data sources. I love it because it also supports incremental adoption. So it'll ship with a REST data sources tool for integrating your existing REST APIs quickly and easily. And then Apollo Federation also allows for a gateway to sit in front of one or more of your APIs, implementing services. There's also Apollo Client, and Apollo Client is awesome because it has libraries for most of the popular front-end libraries, including React and Angular. And then it also has built-in client cache and state management tooling out of the box. And it's really wonderful because it tries to prioritize fetching data from local cache to avoid server hits, so hopefully improving your performance.
A couple other services we want to just talk about. Aws Amplify and Appsync. Great tool chain that Amazon created in order to let you quickly prototype and deploy GraphQL APIs to the cloud. It has first-class support for using Lambda and API Gateway, so you can build out lots of services and GraphQL endpoints very quickly using this. Another one to call out is Hasura. They've made it so you can actually connect your database directly to your GraphQL layer, and it does a great job of actually building out all of your types and resolvers just from your database schema. So definitely don't forget about it. And the only downside with Hasura right now is they only support Postgres and MySQL. So if you're looking for something for your database, be on the lookout. It's probably coming soon. They're always looking to expand their offering.
And last but not least is really cool tools. So I feel like, oh my God, thank you for building these. So GraphQL and GraphQL Playground are IDs for testing your queries, mutations, and subscriptions. The really cool thing is they connect to your GraphQL endpoint and allow you to explore your schema side by side. And Playground can also be enabled on your server and directly connected.
And here we just have a quick demo of just GraphQL in the wild. You connect, you can see your documentation. I kind of clicked through and kind of showed how some of that works. And here, what's really nice is you can actually, you get some auto completion, but you can see this is the Star Wars API. I'll post a link in the chat, but it makes it so you can go through and just kind of look at specific information. You get these nice auto completion fields. So if you want to explore more data, it absolutely gives it to you. And it's just a really handy way of kind of debugging and understanding how things go. It also lets you insert queries and other information as you go.
Yeah, it's like so magical. When I first discovered this, I was like, oh my God, life is amazing. Another thing is, our company. So again, super happy to be platinum sponsors of this event. You should definitely check out the Twitter handle, this.media. We just hosted State of Accessibility today. We host things like State of React, State of Angular, State of Vue with the different core teams, just like we do State of GraphQL. So check that out. And again, if you want to come work with us, we're a team of about 50 developers. We're 100% remote worldwide. And, we just love amazing people. So looking for mids, seniors, if you're a junior, like apply to, who knows, right? And also staff engineers and engineering managers. So there's a lot of opportunity here, and it never gets bored, right, Dustin? It never gets boring.
Never boring at this dot.
Thank you all for listening to our talk, and find us on Twitter at LadyLeet and at Dustin S. Goodman. And we're always happy to chat more.